Okay, this is week 6 notes. What we're going to start out doing is a process called implicit differentiation. So the derivatives we've done before, we always had, like for instance, y equals x squared or something like that. And we said the derivative of y was y prime, or the derivative of y we said was dy dx. And the derivative is, this is the power rule, is 2x, okay? So that's what we've been doing, where we had, y equals and then some x's, and so we just kind of went right into y prime and figured out the derivative, and we were done. So now you can see with this problems is it's not y equals anymore. The equations are like number 2 is much more complicated. You cannot solve for y in any of these and then take the derivative. So you have to use a process called implicit differentiation. So I kind of put an easy one here to begin with. So let's start with the first one here, and write it a little differently to start, and then you'll kind of see what the pattern is. So the way we're going to write y squared is we're going to kind of write it like we did sometimes other times when the center was kind of complicated. All right. So when you do the derivative of y squared, you do the power rule just kind of like you did before when it was an x. So 2 times 1 is 2, and then y goes to the first power. And then if you remember, you do the derivative of the inside. This is kind of like the chain rule. So the derivative of the inside, the derivative of y is y prime. And then equals the derivative of x is 1. So what you can do also, if you want, instead of y prime, we'll finish this up in a minute, but you could also do 2 times 1 is 2, y goes to the first power, and then the derivative of y is dy dx. It means the same thing. And then the derivative of x is 1. So you can write it like this, or you can write it like that. So because we know dy dx means the same thing as y prime. So what I'll do is I'll write it like this. I usually write y prime down. So then to solve for dy dx or y prime, what you do is you just do some algebra. So in this case, you're just going to divide by 2y. So y prime equals 1 over 2y, and you're done. So now the derivative, you can see, or the slope of the tangent line, before was a function of x. We had nothing but x's in there. In this case, we're going to have, in this case, we just have y's, and we're also going to have x's and y's in the derivative, okay, or in y prime. So let's do the next one. The derivative of x squared is 2x minus the derivative of y cubed. 3 times 1 is 3. Y goes to the second power, and then we do the derivative of the inside of this y, which is y prime. All right. Next one. The derivative of 5x was 5. But now the derivative of 5y is 5. And you bring the 5 along, and then the derivative of y is y prime. Equals, derivative of cosine is negative sine. Angle stays the same. And then we have to take the derivative of the angle. The derivative of the angle, the y is the angle, the derivative of y is y prime. Okay? Derivative of 9 is 0. So we don't have anything. So now, in order to solve for y prime, which is dy dx, you have to get all the y primes on one side. So what I'll do is, everything with a y prime, I usually get on the left. So this thing is negative, so over here it'll be positive. This 2x is positive. When you move it over here, it'll be negative. So after you take the derivative, straight across from left to right, you take everything with a y prime and you get it on one side, and then take everything without a y prime and you get it on the other side. The next step, step 3, is you factor out a y prime. Negative 3y plus 5 plus sine of y equals negative 2x. So we factor out a y prime. And then last but not least, if you divide everything by this whole thing here, you will get y prime. Negative 3y plus 5 plus sine of y. So some of the derivatives here can get really messy and look very strange, but that is correct. All right. Next one, number 3. This one here, it probably should show you the angle is xy for sine. All right, so keep that in mind. I probably should have had it in parentheses to be perfectly clear, but usually when they're together like that, that's the whole angle. All right, so here we go. Derivative of y squared. 2 times 1 is 2. Y goes to the first power. The derivative of y is y prime. Equals derivative of x squared is simply 2x. Plus derivative of sine is cosine. Angle stays the same. So now you have to do the derivative of the angle. All right, this is the hard part. The derivative of the angle. You should see 2 things there. You should say product rule. First guy, which is x. Derivative of the second guy. The derivative of y is y prime. Plus second guy, which is y, times the derivative of x, which is 1. All right. So now what I would do is I would multiply everything through and then get all the y primes on one side. So that's a y prime, 2x. These multiplied together are x, y prime, cosine xy, plus y times that is y, cosine xy. Remember, you can't change the angle. Xy is always the angle. You can't multiply anything by that. All right, 2y, y prime, we're going to subtract x, y prime, cosine xy. Everything else stays on the other side because it doesn't have a y prime. All right, good. All right, factor out a y prime, 2y minus x cosine xy equals 2x plus y cosine xy. And now we divide by y prime. So 2x plus y cosine xy over 2y minus x cosine xy. And we're done. Okay, so that one was kind of tricky because the angle was xy and you had to use the product rule to do that. Okay, all right, one up above, so let me erase a little bit. All right. Okay, the next one is a little longer too. At least the left-hand side is. So that's why I kind of cleared some room. All right. The derivative of e to the x or e to the anything is e to the anything. So that's not going to change. But the problem with this one is the exponent. So the derivative of e to the anything is e to the anything, or e to the whatever, times the derivative of the exponent. So the derivative of the exponent is the product rule. First guy, derivative of the second guy. So the derivative of y squared is 2y, y prime, plus second guy, y squared, derivative of the first. Derivative of x is 1. You don't have to put a 1 there, but I did. Equals, working left to right, derivative of 2x is 2. The derivative of 2y, remember you bring the 2 along, and then what's the derivative of y? Y prime. That's a y prime there. So now, same thing. The last one, we multiplied everything through. It really doesn't matter the order. So I'll just kind of rearrange it a little bit just to make it look a little nicer. So I'm just going to rearrange this one. So this one is 2xy, y prime. And then you have to multiply this through. This is y squared equals 2 plus 2y prime. So what I'll do is the 2 disappeared. So e to the xy squared 2xy prime. Move this y prime over, so negative 2y. I'm sorry, negative 2y prime. And I'll move this thing over to the right. So 2 and then minus this thing, e to the xy squared y squared. Factor out a y prime and then divide. All right. So factor out a y prime. So e to the xy squared 2xy minus 2 equals 2 minus ex squared y squared. All right. Y prime equals 2 minus ex y squared over exy squared 2xy minus 2. And you're done. So factor out a y prime and divide by that thing. So it's just a lot of writing once you get the first step. The first step is the most difficult. So if you're going to, when you do these problems, make sure you check over the first step to make sure you have that right. Obviously, everything else will be wrong if you don't. All right, let's go down. So now what we'll do for a couple problems here, and then we'll probably cut the video off here, is you want to find the second derivative. Okay, so if you remember, d squared y over dx squared is the second derivative. You want to find y double prime. Okay, so what you do is you find y prime just the way you did just a second ago. So the derivative of 2x cubed, 3 times 2, 6, drop it a power, minus 2 times 3 is 6, y goes to the first power, and then the derivative of y is y prime equals. Now be careful. The derivative of a number is always 0. Don't put 8 there. Okay? All right. Negative 6y prime. And then move that over to the other side. We'll subtract it. And then to solve for y prime, you divide by negative 6y. Always simplify before you do anything. So this is x squared over y. That'll help you if you simplify. Okay? So now, that's y prime, right? But we want y double prime. So this isn't really too bad. The derivative of y prime, just like before, was y double prime equals. So now you look at this, how are we going to take the derivative of that? Well, that's going to be the quotient rule. So the quotient rule, you start with the bottom guy, derivative of the top, 2x, minus top guy, derivative of the bottom. The derivative of y is y prime, all over bottom guy squared. So this is a y prime right there. So now you can see our second derivative has x's, y's, and a y prime. So what you have to remember to do is to get the second derivative in terms of all x's and y's, you have to sub in. So this first thing, we're just going to rearrange it, 2xy, just to make it look a little nicer, minus x squared. Okay, there's a y prime. So if you look up above, right there, y prime is x squared over y, all over y squared. So now our second derivative is in terms of x and y, all right? So now what you have to do is you have to get rid of this denominator. See this denominator, this y that's on the numerator? You have to get rid of it. So what you're going to do now is you're going to multiply the top by y and the bottom by y, and then that'll get rid of that complex fraction. So this y, you're going to take times this first guy, which is 2xy squared, minus, and then when you take the y times this thing, the y's cancel out, and you have x to the fourth. All over y squared times y is y cubed. So that is y double prime right there. That's the second derivative. All right, last one, and then we'll stop the video, is right here. So this one here is similar, just another practice problem. So derivative of y squared is 2y y prime, minus derivative of 2x, 2, equals, be careful, derivative of 1 is 0. The derivative of negative 2y, bring along the negative 2, derivative of y is y prime. So take a second, you have to move this negative 2y prime over here, so it's positive 2y prime. Move this negative 2 on the other side, which is 2. So now what you can do is you can actually cross out a negative 2. You can divide everything by negative 2, or excuse me, by 2, my bad, by 2. I have all the signs right, yep. So now we have a y prime. And then actually what we'll do is we'll change it back to black, and we'll factor out a y prime at the same time. So when you factor that out, you have a y, and then you factor a y prime out of there. Be careful, you have 1. And then be careful, when you divide by 2, you have a 1. So y prime is 1 over y plus 1. All right? So that's y prime. That's our derivative. So let me erase here. So now you have to find y double prime. So what I'm going to do is one of those tricks I showed you a prior week. We're going to write this a little differently, and it'll make our derivative much easier. So let's write y prime like this. We'll write it y plus 1 to the negative first, right? Derivative of y prime is y double prime, which is what we're trying to find. Negative 1 times 1 is negative 1. Y plus 1 goes to the negative 2. Remember, you always drop it a power. And then the derivative of the inside. The derivative of y is y prime. The derivative of 1 is 0. So now we can sub in y prime. So y double prime is negative 1. Y plus 1, negative 2. Y prime is y plus 1 to the negative 1. So now to go down a little bit, when the bases are the same, you can add the exponents. So y double prime is negative 1. When you add these powers together, it'll give us negative 3. So it'll be y plus 1 on the bottom to the third power, because these will be negative. Negative 2 plus negative 1 is negative 3, and then I'll just write it like that. So that would be y double prime. All righty? All right, that's what's called implicit differentiation. So that's when you have an equation with x's and y's, and you can't solve for y, and you have to do the derivative a little differently. So now number 7, the next problem in the next video is we're going to show you how to figure out the derivative and then find the equation of a tangent line and actually a normal line.